Do I have everybody's? Okay, so the number one, the rate of change function was negative 32t. When it drops, it doesn't, I tried to warn you, it doesn't start at 120, right? That's the height. The velocity starts at 0. So here's our rate of change function, negative 32t. And then you had your choice of how you wanted to do the step function. So I did left. Let's turn this off. It's a little bigger. Too big. There we go. Okay, that's pretty good. So I did left sides, and I told you to use half-second increments. So I just started going. So at this point, I'm not sure when it's going to hit the ground. So I'm just going to keep drawing my half-second step function. And then later I'll find out exactly when it's going to hit the ground. So then I calculated the little bits of change. So for me, at the left, the first was 0. And then this is k delta x. Every time we got constant rate of change, negative 16 times 0.5. So each step is giving me a little bit of height decrease. So then I made my function, this is my accumulation function to the right. Every half second, I'm tracking the height just by adding the next change of height. Hopefully this is familiar, something close to what you did, or this is what you did. Okay, and then I built the function. Okay, so then when I plotted those points, should I make a nice smooth curve through the points? Yes or no? No? Why not?
Because it's got different intervals. So it's not going at a constant slope down. It is, but it's not.
Should I draw a curve through those points? Should I make a nice smooth curve through those points? What do you think, Sterling?
I don't think you want a smooth curve because you want to show like kind of a spike.
Why? Yeah. Why is there spikes in the rates? Why is there kinks in the rates?
Because they're accumulating off from one another, so it's gradually bigger and bigger.
Okay. Why should I draw a line segment and not a curve over there? Somebody else. Patrick.
Because you're taking one point for each of those rates.
Okay.
You're not taking all of the rates at all the times.
Right. So I've got, what is my rate of change function? It's a step function. Constant rate, constant rate, constant rate, constant rate. How is that reflected in accumulation? Constant slope, constant slope, constant slope, constant slope, right? Like we've been doing. So yeah, so this is a piecewise function of linear pieces. Why the linear pieces? Because I'm simulating the falling as, it falls at a certain speed for a half second, then suddenly it's falling at a faster speed for a half second, constantly, and then suddenly it's falling for a faster speed in order to simulate what's really happening. Okay, any questions on this solution or this problem? Ask if you did something differently, and you're not sure. This is mostly review. We've been doing this for about a week and a half. Okay, so what's our goal next? So what we're working on now is getting Graphing Calculator to do this for us. We really got to understand it well, though, if we're going to write it. I'm not just going to hand over to you command lines and use it. We want to understand it so kind of we can write the code, okay? But what's the advantage of using Graphing Calculator? So how can I make this accumulation function more accurate? Jessica?
You could set our interval pretty small.
Okay, so the smaller I make my interval, that step function does what? For a smaller interval, how does the step function compare to the actual rate of change?
It follows them more closely.
Yeah, so it's better, right? It does a better job simulating that rate of change. And so the great thing about graphing calculators, we can set the whole thing up, and then all we have to do is change delta x. And it changes everything for us, and with a click of a button. Okay? So that's what we want, because we don't want to make this smaller and do this again. Right? Okay, maybe you do. You want to do that? And you want to make them 0.1 seconds. So it takes 2.5 seconds to hit. So 0.1 would be 25 intervals. So 25 points, 25 linear functions. You want to do that? So Mason doesn't want to do that. No, good. All right, but graphing calculator, all we have to do is put in the information once with changing quantities. We can make delta x be a parameter that we can change. And all we have to do is change it, and then if we've done it right, suddenly we have a step function that has steps every 0.1 second, and it gives us a much more accurate accumulation function. So that's where we're headed today. We're gonna finish it today. So let's make sure we got the basics down. Anybody have a question? Okay, so let's do it. So let's open up a blank window here. And one nice thing, for some files you make, you'll want it one way. Some files you make, you might want another. But in document settings, if you go to File, Document Settings, and you see here Show Graph, you can show the graph or put the equations to the left or the graph to the right. So that way we'll be able to see everything we have over here going down, and then the graph will be over to the right. So for this particular thing that we're building, I think that's advantageous. Okay, so where does this all begin? We start with what? Where's our starting points? What do we build an accumulation function out of? What's that? The rate of change function. So we'll have our first line be the rate of change function. So we'll call it capital R. Control 9 or Shift 9? Control. We got a function. We're building a function, and so let's start with that one, e to the cosine x. Just kind of interesting curve. And then what we'll do is do comma, and remember that a is our starting point. That's our left side of the interval. So we'll just graph this for, or we'll just define this for x greater than or equal to a. Sorry, take that back. We want to in this line we want to define what a is. Okay, so in this line we're saying we got our rate of change function, and we say this is our starting point. So you can just put anything. We'll just put 1. Okay, and then we want to show that. How do we graph? Is this going to graph the rate of change function? How do we graph it? Say y equals the function. So y equals. And here's where, okay, so here's where we want the x greater than or equal to a, because we're saying where do we want to graph it? We want to graph it starting at a and then forward. So x greater than or equal to a. So we've decided our function, which we can change. We've decided our starting point a, which we can change. Okay, so what's the other parameter that we have here in building the accumulation function? Okay, she said delta x. Right. So let's make delta x a slider. Rather than going up and having to change the number manually each time, if we make it a slider, then we can start it at, say, 1, and then we can just slide to whatever value we want. So on the Mac, you do Option J. Okay, if you're on a PC, you could just do backslash dx backslash if you want. So, oops, backslash dx backslash. You could do that to stand for delta x, or backslash write it out, delta x, like we did last time. But I'm going to use the option J. Okay, so you go equals slider, then parentheses. And so an x interval of 1 is a pretty large interval. We probably won't want anything bigger than that. So we'll go from 0 to 1. And we'll do 50 intervals in between. So this is, I kind of introduced you to this on the test. So 0 is the lowest value that we can make delta x. 1 is the highest value. And then this is how many steps from 0 to 1 that we're going to define. So 50 is good. Okay, so let's graph this and see what it looks like. Everybody gets something like this. So the graph is starting at 1, like we said. And you can go up and change A, make it 3, and then it should start at 3. It'll just graph it always for x greater than or equal to whatever you set A to. Anybody have a question so far? Is everyone good? Or -1. Okay, so the next thing we want is what you had for your homework. I think it was the number 3. We want to show the breakpoints of the intervals, starting at A, and then every delta x. We want to show a breakpoint to the interval. Okay, so how do we graph a point? How do we graph a point? Kyle? Control 2. All right, so we want to graph many points. We're going to do it all in this one command line, but we're going to graph many points, starting at A, and then every delta x along the x-axis, showing the breakpoints of our intervals. Okay, so one of those two is easy. Which one of those two we can just do right away? What is it? If we're on the x-axis? Y is 0, right? So if we want to start at A and we want them every delta x interval. So let's we'll define a parameter c, a changing value. So c is a member of. So the member of, remember, is control equals or control shift E. Is that right? For PC. So here's how we can do. We can just say 0. We can just set this number to just count up by 1, and then we'll put the right formula in the x coordinate to get it to be where we want. So you're going to go 0, comma 1, comma, and then dot, dot, dot. And we can go up to just a lot, 400, whatever, just more than we could need. So the question is, what is our x coordinate of a breakpoint in terms of A, delta x, and C? What is the... Yeah, David, did you get
How do
it?
you put the squiggly?
It's just, you just type it. It's shift bracket, which is kind of above your return key. You see the bracket? Yeah.
On the very top. How do we do the 3 dots?
Control, semicolon.
Thank you.
Control, semicolon. So the question is, how are we going to get these points? Did anyone have a breakthrough discovery during the homework and was able to do it? I'm going to share your success on this. I didn't get any emails asking me a question about it, so anybody get it? Okay, Lizzie.
I mean, I just did like C is the x coordinate, 0 is the y coordinate, C is a member of, and just like delta x, 2 delta x.
Yeah, so it's a little better to put the formula in the x and then just put the numbers as the list. So yeah, so that could work.
But
Yeah.
it's not working when I do that.
Well, because we haven't put the formula in. Right? We haven't told it where to put them. We haven't done anything yet. So how do we tell what are the x coordinates of our points along the x-axis? because A can change and delta x can change, right? We want starting at A and then every delta x after that. So, did someone have an idea? Yeah.
Figured it out a little differently. I think it's point like C 0 in the brackets, comma C is a number of parentheses A plus 0 delta x, comma parentheses.
Okay, yeah, so that's what Lizzie was saying. So that will work. You can put a formula in here, but it's a little cleaner just to have integers as your numbers, and then we'll just put the one formula here. That's what I'm going to encourage you. Yeah, so it works. It totally works. So this is really the idea of a function. This is like the input, and then we have these parameters A and delta x, and then we want the right set of output for any given input. So maybe if we make a table, we could see it a little better. So our input is C. And then we have this x value of point. Okay, so it's the idea of input and output. So when C is 0, what should we get? What x value should we graph the first point at? What's that? A, right? We said we want to start at A. Okay, so then what about the next point? Somebody else. Reshma, where should the next point be? A plus delta x. And this is what you guys were saying. Okay? All right, so Amy, where should the next point be? So we got our first one at A, then we're going to move over delta x and put our second one. Then where should the next one be? Trevor, what do you think?
A plus 2 delta x?
A plus 2 delta x, John Paul. That's what he's going to say too. Yeah, that's right. So we're again, and we're going to go over 2 delta x. Okay, third one. Isabella. Yeah, so it's easy now once you get started, right? It's those first couple that you really got to think about. So now the question is, what's the formula given this value, this integer c, what's the formula for the x-coordinate of that point? She wants a plus c delta x. Erica, you like it? Let's try it. So we go in here and we put a plus c delta x. And let's make those, we'll make the function blue, and let's make those points red on the x-axis. Let's see if it works. Doesn't work. What happened? Where's my slider? Oh, it's because I got my delta x at 0. So let's put delta x at 1. So put delta x at 1, and it should work. So,
Yeah, I don't have it. I don't really know why.
did you delta x equals slider 0, 150? Did you open it up and so slide this over to show it? Other questions? Yeah.
Yeah, I didn't fix it.
Do you have a line like this? But you don't show a slider there? You're saying yes, you're not showing a slider?
Yes.
Is this just PC people? Is this Mac people too? Well, erase that line and try it again.
Okay.
So delta x equals, type out slider.
Delta, like the sign delta, I changed mine to EX.
Yeah, it doesn't work.
And then it worked.
Slider
Delta x should be working also.
Okay, I'll just try it.
Yeah, just start over. Put in delta x and then equal, then type out slider, and then 0, 1, 50, and the slider should appear. Are there more people that aren't getting a slider, or is it just a couple?
Just type in slide.
Oh, like if I put D, it works.
Yeah, so go ahead and do
Oh,
there you go.
yeah, I don't know why that's
Everyone got it now? So now, slowly move this. So what's going to happen if we slowly move the slider and make delta x less? What's going to happen? It's going to show that breakpoints are going to be showing closer together, right? So make it 0.5. So now you're showing that breakpoints at 0.5. Okay, then you can change A. So make A, if it's -1, you could make it back at 2. And now it's going to start at 2, and the delta x will be 0.5. So we have control over the starting point, and then what delta x is. Anyone having issues? Yeah.
So you're like the dots on anything when you slide it?
What does that mean, though? The dots are moving.
No,
So
I was like,
like-
how does using a slider?
what is the slider doing? What is the slider doing? It's changing what? What quantity is the slider?
Well, I just got my physics now.
Yeah, because you say you call it dx here, but then you call it delta x there. You see? You gotta keep you want this to be the delta dx. Anybody else? Yeah, that's fine too. Do it that way. There you go. Okay, everyone got it. What's that? Choose dx. Do \dx. Oh, what's your sign? Oh, okay, that's
Oh, yeah.
I guess you gotta erase this and you see the x. Like the dx. No, you don't do that. Just erase the cdx. Retype the whole thing. cdx. That's what I'm. There you go. Okay. Any other issues? Okay. So the question is now, what do we do next? What was our goal? We're going to build the accumulation function. We've got the rate function. We've got our intervals. What's next? What's the process that we've been doing for a couple weeks now? What would be next? What's that? Step function, right? Step function. What is a step function? Jason, what is a step function?
Shows the rate of change.
The actual rate of change?
Like steps for what you take per second, or whatever.
Okay. How does it compare to the rate of change function that we have? Is the step function? What is the step function related to this Rx that we start with? Ben? Is it just like choose one or the other, no big deal? Like we just got two of them, or what is the step function that we're making relative to the original Rx?
It's going to be the rate of change at a given interval for R of x, or for e to cosine.
Okay, so it will be the rate of change. David, what do you think about that? You don't know. Why are we making these step functions? What are they? What's that?
estimates.
Estimates, say more.
They're estimates of the rate of change of that.
Okay, yeah. It's a simulation of the actual rate of change. Right? That's what we said. Step function is, when we make that step function, we're simulating the true rate of change function. Why are we doing that? Why can't we use the real rate of change function? What's that? Okay, and why? So what about that? Go ahead. Patrick, go ahead.
You're
gonna use the step function because it's easier to calculate. Because there's less values to plug in. So you're gonna use the intervals instead of every single point.
Yeah, every single point, even just in a tenth of a unit, would take us, the rest of our college career. Okay, so the step function, there'll be less things to calculate, but then a constant rate of change is convenient, right? Why is it convenient? How can we get little bits of change with a step function? Brian, up here, this Brian. This Brian. Why is working with constant rate of change convenient mathematically?
Easy.
Why? What's easy?
We have a formula for it.
Which is?
Sorry,
Tony. Why is constant rate of change convenient? Jason.
it's predictable.
Predictable, okay? Yeah. Okay, what's proportional? That's right. We can get little bits of change. You can't forget everything we've learned, you guys. You can get little bits of change by doing what? K times delta x. You can't do this with changing rate of change. You can't do this with changing rate. That's why we simulate the changing rate with a step function of constant rates, so we can use proportionality of changes and easily calculate little bits of change. Go back to the video and play what I just said 1,000 times. Okay? All right? Really important. So we got to make a step function so that we have a fighting chance to build an accumulation function. Okay? So we can use some mathematics that'll do it. Okay? So what's the idea of the step function? Let's, I'm going to change, yeah, this is fine. We'll leave it here. So what will the value of the step function be when x is right there? We're going to use a left-hand step function. Okay, so when x is this value right here, what's going to be the value of the step function for that x value right there? Allie, what do you think? If we plug in x where I said right there, and we're going to use the left-hand side of the intervals to do our steps, what's going to be the value of the step function? 3. The value of the step function will be 3. Agree with that? I see a lot of nodding heads. It's not right. What will the value of the step function be? Was in?
The rate at 3?
The rate at 3. R of 3. Okay, so you were looking in the right place. Yeah. But 3 is an x value. The step function will be R of 3. Okay? Will be R of 3. So what about here? Ryan, what will be the value of the step function in that second spot that I drew? R of 6. R of 5. One more try. We're at delta x is 0.5. Look on that side. R of 5.5, okay? Remember that little exercise we did? Okay, so take a look here. So I got this. So what I want you to do is, given r and delta x is 0.5, what will these, talk to the person next to you, what will these r values be? Okay? What will these r values be at those values of x for the step function? Go. So for any rx, any rate function, and delta x is 0.5, what will the value of the step function be? Oh, sorry.
It would just be. Oh, right, right.
So if it's 0.9, it'll be like
And A is 0, okay? A is, I'm showing A is 0. The first point is at 0. Yeah. Okay, Megan, what is going to be step of point 4? 0. What do we think? Step of point 4 is 0. John Paul agrees. Isabella? R of 0. Which one? 0 or R of 0? Erica? R of 0. Okay? Point 6. So step of point 6. Jack? R of point 5. Point 8. Alexis? R of point 5. Point 1. Danny? R of 0. 1.2. Brian Kirk? We getting it? R of point 3. Yvonne? R of 0. That's right. How about step of 0? Mason? R of 0. 1.1. Step of 1.1. Eric? R of 1. Okay, so are we getting the idea here? So the question is, given an x value, where does the input for r come from? Where does the input for r come from given an x value? So let's just do the inputs into r that will give us the step function. All right, we'll do that in between. So this row is going to be now, what input are we putting into r to get the value of the step function? So tell me. What input am I putting in here? Zero. What input do I put in at point 1? Point 2. Point 3. Point 5. 0, right? No, point 5. Where does it change from point 5? And then how are we going to put in? 1. So we have the actual x value, but then we have the x value that we want to put into the rate function to get the step. You see? There's the actual x value, say 0.3, but to get the step at 0.3, we want to put 0 into r of 0. And we've got the actual x value 0.8, but to get the value of the step function there, we want to put 0.5 into r. So what is this function? We need so we've got another kind of function here that takes our real x value and makes it the right x value to create the step function. What is that? If you're staying up and doing your homework, you should recognize that.
Isn't that our formula that we came up with?
What, for what?
The a plus x minus a over delta x.
Last 2 classes and in your homework, that's our left function, right? That's that left function. We plug in an x value, it's going to crank out the x value at the left side. Remember doing that with the worksheet? So the question is, how do we write this step function? What is it that we're putting in to the step function? What x values are we putting into the step function? What's that?
The ones on the left.
The first row or the second row?
Second row on the left.
So we're putting in the output of this left function. What are we doing? We're putting it into the step function. So the step function is really, what we need to put into it is the output of this function that gives us the left side of this. So how can we show that on graphing calculator? We want to write the step function. So first let's create the left function as a line. So our next line we'll do, oops, here. So we'll call it left. So backslash left equals, who remembers what it is? How do we get the left side of the interval that x is in? One person remembers. Kyle, Kyle, want to give a shot? Okay, so to get a floor function, you just type floor, and it pops up. And what did you say? Well, n was representing our x values. And I think you want x minus a, right? You want to start final minus initial. You want x minus a, and then we divide by delta x. Is that our left function? Actually, we need to, when you go back to the left there, we need to make it a function. How do we do that? Function of x. Control 9. Okay. Yeah.
How do you do delta x again? I'm sorry.
However you defined it. You're going to keep doing it the way you defined it. You just type it now.
I just mean
But how did you define? You didn't define it as delta x. You used dx. So now every time you have delta x, you're going to type dx. Okay, is this our left function? Jessica, what is it?
What's the A plus?
A plus
And then
times delta x again. Okay, is that going to graph anything? No, that's just establishing this function of taking any x value, we worked on this for a couple days, and spitting out the left end. So now we're ready to graph the step function. See if you can do it. Can you graph the step function? Remember what we talked about here, down at the bottom of the screen? How do we graph the step function? Oh, so call it, just so we're all doing the same thing, call it g of x. G of x is going to be our step function. Okay? So call it g. So g, control 9 of x. How will we get graphing calculator to graph this step function? I'll move that thing up again. A little higher. There we go. So remember what's going on here. So we got x is all the real x values. Left then gives you the left sides, and that's what we want to go into the rate function to create the step function. Anybody think they got it? Is that uh-huh? Let's see. You're just graphing left. You're just graphing these. You're just graphing these values. These are the new x values. Remember what it should look like. It's going to try to be matching the curve. Nice. Okay. Some of you are just graphing the left function, and you're just going to get a stair step up, and it's not going to, yeah. The step function is not the left function. What is the step function? It's simulating our values at these values of x. Let's see, anybody can think of it? The left function just gives you x values. It just gives you x values. So that's not the step function. Is it working? Just gonna graph it. So do a new line and graph it. It works. So, it's just so it works. See if you are getting it. See, the step function is a function of the rate, but we got to put the right inputs in. We don't want to put x in. What do we want to put into the rate function? The output of the left function. How do we write that? So whatever the output of the left is, that's what we want to put into the rate function, and that's step function. Question? Sure. Yeah. Got it. Graph it. So do a new line and graph your g and see if it works. And now play around with delta x and a and see if it works. This is the color. This is the blue. That's good. Is that right? Is that doing what it's supposed to do? So if you want g also to start at a, you need to tell it. You want it to start at a. No. Okay. So what do we want to do? So the step function is very much like the rate of change function, but we're altering the inputs. So it's going to be r. You're just graphing the x values, the x left values. Still, it's a rate function. Still a rate function, but with different input. What input now do we want in the rate function? Yeah, nice. So rather than putting x into the rate function, we want to put what into the rate function?
R left of it.
Left goes into the rate function. So these new x values that are at the left sides of our intervals, that's what we want to put into the rate function to give us a step function. And you can do that for, oh, that's fine, okay. And then to graph it, y equals g of x. And you can do the same things we did before. You can start at a, so you can for x greater than or equal to a. Pick a good color. Now there's, all right, so is everyone able to do it? We're putting the left values of every x into the rate function to create the step function. This should make sense, right? So change all the x into their leftmost x values, and now graph those as rates, so you get steps. Now there's something weird about this. Something should feel uncomfortable when you see this picture. Yeah, the vertical lines, okay? So what is Graphing Calculator trying to do that we don't want it to try to do? No, it's not really thinking delta y. It's graphing what we told it to graph. And so what is it doing?
It's trying to be like a connected.
Yeah, it's just trying to connect every point. Okay? So it's connecting every point. It gets here and then it connects it to the next point. So the way we can fix that is we can tell it to only be defined everywhere except at the breakpoints. So where are our breakpoints? What values of x are our breakpoints? What's that?
Every point value.
Yeah, but we want that to be able to change it. As we change delta x, we want it to change too. So aren't our breakpoints, these are our breakpoints, right? So copy that. So if we look at every x value like that, we don't want them to be equal to the floor. So not equal to on the Mac is option equal.
We have to prove the floor.
Yes, you do. Because we're saying we're going to take all x values and do that ratio. We don't want the ones where you actually get the exact floor. Option equal. Option equal is not equal. That should take away what we call the drool. This is the calculator drool, right? It's like falling down. It didn't work.
Yeah, I'm not.
Look in keyboard shortcuts. I'm not sure. Anyone found not equal? So sorry, it's not comma, it's if, okay? So we have this condition. So rather than comma, we want if. And so we got to start over. Sorry. So if, okay, if x minus a divided by delta x is not equal to the floor function. That should work. There it is. All right. Issues. Needs help. What's that? Anybody figure out not equals on a PC? Control Shift N. Control Shift N. Thank you very much. Oh, because you got delta x at 0. There you go. Now, do a better color so you can see it. There you go. Now I gotta get rid of the rule.
I just copied it.
Issues, questions?
So he said Wednesday was step. Because those are the options.
The only difference is that we have a different results. Everything else is we have an option, it's the same thing. But we have a control, which is different. Control option. So that's an object.
You shouldn't try to have that function.
Oh no.
So I would rewrite this line. See, it's graphing the word. It's not setting up a function. It's graphing. Anybody got questions?
That's
Okay, so here's the great thing. What can we do? So we've got this step function. How can I make the step function more realistic? What is a step function? Trying to simulate the actual rate of change function. How can I make it more realistic now?
Your slider down.
All you got to do is grab delta x, make it small. Let's make it real small. 0.06. Okay, now I'm going to turn off the graph, and what do you see? Watch. So this is a step function. These are all constant rates. But what do you see? It's basically the original graph. You step away a little bit, and you can't see it's a step function anymore. It's so, delta x is so small, it's doing a fantastic job of simulating the actual rate curve. Okay, leave the function off and make delta x big again. How about that? Doing a good job? You can't really, I mean, you can kind of see that it's going down and then back up and then down like a, it's like cyclic thing, but you can't see it like, look at that. That's a step function. Those are constant rates of change. Okay, if you have more calculator issues, I'll stick around and help. Quiz tomorrow, not on this stuff today, but last week's stuff. Everything up through the homework that you turned in today. Quiz tomorrow.
Wednesdays and Mondays, like,
Oh, yeah. Hello. I'm sorry. I don't think you're outside yet. And that, that's what I call.